Since the dawn of time, humankind has chased one impossible dream: immortality. From ancient alchemists to emperors to modern billionaires and biotech labs, the obsession has never stopped. We don't just fear death, we try to solve it. Because from our perspective, aging feels like a law of nature, unbreakable, final, absolute. A one-way road that every living being eventually walks. No exceptions, no escape. But what if that assumption is wrong? What if nature itself already found a way to bend that rule? What if immortality isn't something waiting in the future, hidden in some sterile lab, but something already alive, right now, in the deepest parts of our oceans? Because on this planet, there are animals that do not age in the way we understand it. Some barely show signs of biological decay. Some live for centuries, some for thousands of years, and a few appear to reset time itself. In the most extreme environments on Earth, evolution created something almost impossible: living time machines. Sharks older than nations, corals older than pyramids, jellyfish that can reverse their own life cycle. These creatures were never supposed to exist, and yet they do. Today, we're diving into four of the most extraordinary animals on the planet, creatures that seem to have broken the rules of death itself, and hidden inside them may be the blueprint for something humanity has been chasing for thousands of years. Our journey begins west of Ecuador, a remote volcanic archipelago, the Galapagos Islands. First documented in 1535 by Fray Tomás de Berlanga, the islands were described as harsh, isolated, almost alien, a place where life should struggle to survive. And yet, it thrives. Most famously through the Galapagos giant tortoise. These creatures move slowly, almost timelessly, but their real secret is not movement, it's duration. Galapagos giant tortoises regularly live more than 100 years. Many exceed 150. And what makes them truly fascinating is not just how long they live, but how slowly they seem to age. For decades, scientists have tried to understand this phenomenon, because in most animals, aging is visible, predictable, unavoidable, but in these tortoises, it is dramatically slowed. A major international study led by Penn State University found that reptiles such as turtles and crocodilians show extremely low rates of senescence. Senescence is the gradual deterioration of cells and biological function over time. In most species, it accelerates with age. In tortoises, it barely progresses. One major reason lies in metabolism. Humans are endothermic. We generate our own body heat constantly. That sounds powerful, but it comes at a cost, because that internal engine produces reactive molecular byproducts every second. Over decades, this creates accumulated cellular damage, a slow biological wear and tear. Tortoises operate differently. They are ectothermic. They rely on external heat sources, which means their metabolism runs slower, more efficiently, with less internal stress, less energy burned, less damage created, less biological noise. But the real surprise comes at the genetic level. Researchers at Yale University discovered that the genome of Lonesome George, one of the last Galapagos tortoises, contains gene variants associated with extremely efficient DNA repair. Even more interesting, damaged cells are often eliminated through apoptosis before they can become dangerous, a built-in safety mechanism, a constant biological cleanup system running in the background, a living system that repairs itself before failure can occur. The Greenland shark. Now we leave warm waters behind and descend into the freezing Arctic depths, a world of darkness, pressure, and silence. Here lives the Greenland shark, the longest living vertebrate known to science. Some individuals may live 300, 400, possibly up to 500 years. Think about that. An animal that may have been alive before modern science even existed, before electricity, before industrialization, before most of recorded history as we know it. But for a long time, nobody knew its true age, because sharks are difficult to study. They have no bones, no growth rings, no obvious aging markers. So for centuries, their lifespan remained a mystery, until 2016. Scientists at the University of Copenhagen discovered something unexpected. Inside the eyes of Greenland sharks are proteins formed before birth, and these proteins remain unchanged for their entire lives, like biological time capsules. By using radiocarbon dating on these eye tissues, researchers made a shocking discovery. One female shark was estimated to be nearly 400 years old. This means it may have been swimming in the oceans while the Great Fire of London burned in 1666. It witnessed centuries of human history pass by, without ever changing its pace. always slow, always steady, moving at less than 3 kilometers per hour. But that slowness is not weakness. It may be survival strategy, because in the freezing Arctic, metabolism slows dramatically. Energy consumption drops to a minimum. Cellular processes run in extreme slow motion. Biological wear is reduced to almost nothing. Even enzymes in the shark remain unusually stable over time. While most organisms accumulate damage and break down, the Greenland shark appears to resist that process almost entirely. It does not age like other animals. It simply continues existing. Black coral. Deep beneath the ocean near Hawaii, far below sunlight, there are living structures older than entire civilizations. This is black coral, Leopathes anosa. Some colonies are over 4,000 years old. To put that into perspective, they were already alive when early human civilizations were just beginning to form. While empires rise and fall above the surface, these organisms continue unchanged below. Their strategy is extreme stability. They grow at an almost unimaginable rate, micrometers per year, so slow that change becomes almost irrelevant. This slow growth reduces structural stress and biological damage over time. The outer polyps continuously regenerate, replacing themselves over thousands of years, while the internal skeleton remains intact for millennia. No sudden shifts, no instability, no rush. Just continuous existence in a stable, deep-sea environment. No storms, no seasons, no chaos. In that environment, time loses urgency, and black coral becomes one of the oldest living systems on Earth. The immortal jellyfish. But now we reach something even more extreme, something that doesn't just resist aging, but reverses it. Meet Turritopsis dohrnii, the immortal jellyfish. Tiny, almost invisible, but biologically extraordinary. When faced with stress, injury, or starvation, it does something that defies almost every rule of biology. It reverses its life cycle. Instead of continuing toward death like most organisms, it collapses inward and transforms back into its juvenile polyp stage. Within approximately 36 hours, it becomes young again. Scientists call this process transdifferentiation, cells changing identity completely, reprogramming themselves into different cell types. It is like a butterfly turning back into a caterpillar, not once, but repeatedly, potentially indefinitely, meaning in theory, it may never die from aging. Japanese scientist Shin Kubota has dedicated years to studying this process in controlled environments, observing colonies as they repeatedly rejuvenate themselves under stress conditions. For humans, this ability remains far out of reach, but it offers something powerful, a glimpse into biological reset mechanisms, a possible future where damaged cells might one day be repaired or replaced or even reversed. Across all 4 animals, a pattern emerges. The Galapagos tortoise slows aging through protection and repair. The Greenland shark survives through extreme metabolic slowdown. Black coral achieves longevity through absolute structural stability, and the immortal jellyfish pushes further by reversing biological time itself. Different strategies, same outcome: resistance to aging. And together, they reveal something profound. Aging is not a fixed rule. It is a system, and systems can be understood, maybe even changed. Evolution has already discovered multiple ways to slow, resist, or even reverse time inside living organisms. And somewhere within these animals may lie the biological blueprint for something far beyond what we currently understand. Not just longevity, but control over life itself. The question is no longer whether aging can be challenged, but how much of it nature has already solved without us noticing.